Condense, don't touch anything if you prefer my method. We have to state the domain on the raw equation. Don't condense, don't touch it. So the condition for this is x minus 4 positive. The condition or the restriction for this is x plus 1 positive. And of course for that at x minus 8 positive. I already see that this is greater than 8, this is greater than 4, and this is greater than -1. I know the answer, but let me show you. It's greater than 8. But let me show you how we get that. So I'm going to use 3 different colors. Blue, greater than 4, is this one. Black, greater than -1, is this one. And greater than 8, whatever this color is, I don't know. Silver. So we are interested in all 3 colors. Then all 3 colors are definitely here. From 8 to infinity. So this is it. So the common domain is 8 to infinity. If I do not get an answer or answers that are greater than 8, not 8, then equation has no solutions. Now I will condense. And by the way, I want to choose one with a difference as well. Because we did, this is the second one with the product. So this is natural log of x minus 4 times x plus 1. And the other side is natural log of x minus 8. Okay, I have to go back to this for 1 second. When we solved these exponential equations with the same base, here's an example. 2 exponential notations are equal, and they have the same base. We immediately set these 2 equal to each other. Because this cannot be 5 and this 10. 2 to the 5th will not equal 2 to the 10th. They must be equal. So the same idea here, the function is 1 to 1. So I have now 2 logs in the same base that are equal. Can this be 5 and this 10? No, because log 5 does not equal log 10. So because we have the same base on both sides, this must equal this. So x minus 4 times x plus 1 must equal x minus 8. There is no other way. So now I will distribute. This becomes quadratic. So this is x squared plus x minus 4x minus 4 minus x plus 8 equals 0. And then I see x squared minus 4x and plus 4. And we know this from 3 months ago. Almost. X minus 2 squared equals 0, so x equals 2. What do we conclude?
No solutions.
No solutions. Great job. Let's look at one with difference. So we can condense so you can see what happens with the difference. What about 90? Any questions on this problem? Any questions on this problem? Okay, so 90. And then we move on. Unless you have questions, of course. I see log base 2 of x minus 1 minus log base 2 of x plus 3 equals log base 2 of 1 over x. First condition, x minus 1 must be positive. Second, x plus 3 must be positive, and 1 over x must be positive. So I start with 1 over x because we have not seen something like this before. Well, this is positive. What kind of number should x be for the quantity to be positive? If the top is positive, the denominator must be positive. Otherwise, the ratio will never be positive. If this is negative, positive over negative will not be positive. So from here, this is a very simple situation. I just want to make sure that x is positive, because otherwise I will not have 1 over x being positive. This one says greater than 1, and this one means greater than -3. Since they're all greater, it's the larger one. 0, so -3 to infinity, 0 to infinity, 1 to infinity. So this is it. The common domain is 1 to infinity. At this point, I can condense. And I know how to condense that, since it's a difference, is log base 2 over ratio. What ratio? The one with minus in front is coming from the denominator. The log that has positive in front, if it doesn't have anything, it's positive, its quantity is coming from the numerator. The right-hand side is log base 2 of 1 over x. I don't need to change this into an exponential. There is no need, because I have 2 logs that are equal in the same base. Their quantities must be the same. All I have to do is set these two equal to each other. And I will do just that. And this is x minus 1 over x plus 3 equals 1 over x. Back to my list. What kind of equation is this? Initially, it was a log equation, logarithmic equation, but what type of equation is this now? Linear, rational, quadratic, polynomial, radical, absolute value, quadratic in form, equations with rational exponents, exponential log. Which one? It's a rational, also a proportion. I love proportions. X times x minus 1 equals x plus 3 times 1. Distribute, x squared minus x, move, 0. So this is x squared minus 2x minus 3. Can anyone give us the factor form of this? That would be great. Anyone?
X minus 3 times x plus 1.
Excellent. We can always check x squared plus minus, it's correct. So then we get x equals 3 and x equals -1. And you should say, not so fast. And I will say, yes, I agree. Not so fast. What?
It's x equals 3.
X equals
Negative
-1.
not-
Yep. Very good. I'm hoping that you're going to practice this, and we're going to choose more problems very soon. Sometime next week after you do your homework. Moving on to the last section. I'm guessing I just punched in 5:30. Let me see. Yes, actually, it's good. Okay. So let's look at more applications. That's the last section of chapter 4. So 4.5, applications. We had a lot of applications, but we still have to look at a few more. So 2 applications that come to mind right away are these. A equals P, 1 plus R over N raised to NT. This is the interest compounded N times per year. Interest compounded n times per year. Then we have compounded continuously. You do not need to memorize any of this. They will be given to you. So here, interest compounded continuously. So this is the first application, the second application. There are so many, but we are only going to look at 3 more. One of them is something called logistic growth model. You don't have to memorize it. It will be given to you. And we're going to start with a problem like that. And 2 others, and you're going to tell me if you see any resemblance here. A of t equals a0 e to kt exponential growth and m of t. Your book uses the same notation. I'll explain to you why I'm using the different notation, but it doesn't matter. Exponential decay. Do you see any resemblance? You cannot see any resemblance with this. Obviously, I didn't even present one. We're going to look at examples in a minute. Of course, you cannot say anything about that because it's by itself. But do you see that these 3 are basically the same model? Just notation is different, but it's the same model. The only difference is that R and K will be the same thing. There is minus here for the exponential decay. So these 3 models are pretty similar. Okay, let's start with the logistic growth model. And problem 37 on page 530. The logistic growth function, f of t, equals 100,000 divided by 1 plus 5,000 times e to negative t, describes the number of people, this is relevant today, f of t who became ill with the flu t weeks after its initial outbreak in a particular community. So, taking notes, t in weeks, f of t, number of people, who got the flu in that community. Question part A, how many people became ill with the flu when the epidemic began? So in part A, remember initial, original, beginning. These are the key words. What does this really mean when we're asked to find the initial, the original, or beginning? What am I asked to find? Always. When t equals, of course, f of 0. That's the question. Every time you see the word initial, original, or beginning, or these keywords should indicate to you f of 0. We're going to come back to it in a minute. Part B. How many people were ill by the end of the 4th week? What do you think that is asking us to do? Excellent. We'll come back to it in a minute. What is the limiting size of the population that becomes ill? So by limiting size, We really want the end behavior. In other words, I was asked to find f of 0, f of 4. I'm going to move on to t equals 10, t equals 100, t equals 1,000, and see what happens. Of course, we cannot do this by hand. So let's grab our calculators in y equals, clear whatever you have, and be very careful how you enter this function. Because the numerator is just one term, there is no need for parentheses around the numerator for one term. But if we don't put in the calculator parentheses around the denominator, and I will always put parentheses around the power, no matter what the power is, because that's what makes me feel comfortable. I know these new calculators, whatever, don't require that, but I don't know what type of calculator you have anyway. So because it's only one number, I will not put parentheses or one term around the numerator, but I will definitely have to put parentheses around everything is in the denominator and also the power. We don't have t in the calculator, we're going to put x. So 100,000 divided by, in parentheses, 1 plus 5,000. Remember, e is paired with natural log. That's where it belongs with its inverse function. I will put parentheses for the power. In some cases, in your calculator, it may pop up. The parentheses may pop up already when you click that. So tell me when you have this. And then we'll go to second and table. And we're going to plug in all these numbers. 0, 4, 10, 100, 1,000, and make our conclusion. Okay. We all have this. So second and table. 0. So initially, I cannot say that I have 19.99. I'll have to say, well, it appears that 20 people were infected initially. Then I will plug in 4. Then I will plug in 10, and then 100, and then 1,000, and then we'll draw conclusions. So for f of 4, see how this function works? So at the beginning, at 0, initial outbreak, 20 people. But look what happened in 4 weeks. 81,500 people got infected. Oh, no, I think that was 10. Sorry, this was 10, for 10. So f of 10, I jumped. 81,500 people. And for 4 is 1,080. In 4 weeks. So, conclusion. Let me also copy the other ones. So f of 100. For f of 100, I got, of course, 100,000 people. For f of 1,000, of course, I got 100,000 people, and so on and so forth. So what is the limiting size of the population that can get ill? Not more than the number of people we have, assuming that nobody comes to visit from the outside. So in other words, as t approaches infinity, the function values approach 100,000. So y equals 100,000. Of course, if you remember, it's a horizontal asymptote. We're not asked to write that. It's okay. But that's what happens. So this is how we deal with the logistic growth model. I would like to add a question here. If you want to go back to the book on page 531, we see 2 other logistic growth models, problems 38 through 42, and also problems 43 through 46. I encourage you to at least look at those. I want to add a question here. because these problems have that question. I want to add it in. When will the number of people when will the infected number of people, infected number of people, when will it reach 20,000? What do we need to do now? Well, I thought that this is the number of people. Now I'm going to have to replace this, the y value, by 20,000 and find the time, t. So 20,000 equals 100,000 divided by 1 plus 5,000 e to negative t. And here's my first hint to you. How do we start? It's a complicated type of equation. It's not an easy, breezy type of equation. So it's a proportion right now. So I'm going to cross multiply. 1 times 100,000 equals 20,000 times the denominator. That's my first step. Next step, after I cross multiply, 20,000, I'm going to write them without multiplying just yet, e to negative t equals 100,000. And remember what I always say. I know I repeat myself a lot. Of course I'm going to simplify. I'm going to divide both sides by 20,000. So from the very beginning, I can cross out 4 zeros, and then 10 divided by 2 will be 5. What will be our next step? What do you think? Just common sense. What will you do next normally?
Subtract 1.
Exactly. Thank you very much. So 5,000 e to negative t equals 4. What will you do next? It can still be cleaned up. Dividing both sides by?
5,000.
Exactly. So then e to negative t is whatever this number is. I don't care to even find it. You can simplify by 2 if you want, by 4. It doesn't matter. What do I do now? Because I'm solving for t. And both sides cannot be presented with the same base. There is no way. So what is my only chance now? Somehow to bring this negative t in front. What should I do to both sides to bring the negative t in front? Natural log. Negative t, natural log e is 1. Natural log of 4 over 5,000. The only thing I need to do is divide by negative 1. Or multiply by negative 1. Same thing. So t equals negative natural log 4 over 5,000. Okay, calculator. If you start with a negative, you have to start with a small negative, not with the operational negative. And then natural log. And then 4 divided by 5,000. Close the parenthesis and press enter. 7.13. What is 7.13? So approximately 7. 7 what?
Weeks.
Thank you. In 7 weeks, this epidemic started from 20 people, and in 7 weeks, 20,000 people got infected. Great job. Thank you. Okay, so now we have to look at these two, which are the same. The only difference is here. Okay, so on page on page 529, choose from 7 or 8. You want to talk about the population in Israel, or you want to talk about the Palestinian population? Whichever you prefer.
Israel.
Fine. So problem 7 on page 529. They're so interrelated. That's the same situation. Okay, in 2000, let me see my video here.